So this is the first section of stats. It's called organizing data. And in this section, we're going to talk about something called a frequency polygon. So the very basics of what it's actually going to be about. So just bear with me. The first couple pages are going to be pretty boring because there's a lot of definitions. But once we get into, the major definitions wise, we'll have lots and lots of examples, based off those portions. So just bear with me. Again, right, it's the first steps of, what a stats is all about. So why don't we just go slowly through that kind of stuff, okay? So first definition is called a frequency polygon, or sorry, a frequency distribution. Okay, so frequency distribution shows how the data set is partitioned among all the several categories. Now, partition is a fancy word for saying breaking up. So we're just breaking up the data set. That's pretty much what that means. Okay. Now, when it comes to categories and classes will mean the same thing. So when you see these two, you think of the same concept. Okay. Well, I'll introduce classes now, and it's a little bit like this. For now, we use categories, but we use classes later on in the course, anyways. So vice versa. So I'll read it again. So it shows how the data sets partition among all the several categories or classes by listing all of the categories along with a number of data values. Okay. And I'll give you an example of what I mean by that in a little bit. Okay. The next major definition is called a frequency. Okay. So the frequency is the number of original values that fall within that class. So here is an example of what a frequency distribution looks like. Okay. So these are called the classes or the categories. Okay, so there's ages, so it labels it in these portions, and this is the frequency. So this is the frequency definition corresponding here. So the number of original data values. So what this means is, so we have 10 values or 10 numbers in my data set that are between 16 and 20. So in this case, I have 10 people that are the ages from 16 to 20. I don't know what they are, if they're all 17 or all 20s, but I know I have 10 people within that range. So that's what a frequency means. And it goes straight down, right? And 8 means I have 8 people within the ages of 21 to 25, 2 people between 26 and 30, 7 people between 31 and 35, and 13 people between 36 and 40. Also, basically what a frequency polygon is, it's a way to have, instead of random numbers everywhere, it makes it nice and pretty to look at, essentially when it comes to it. Now, on top of this, we have this little pusher here. So this says so the classes, if you guys know what the classes or categories are, these are the classes themselves. These 5 here. So there are 5 classes: 16 to 20, 21 to 25, 26 to 30, 31 to 35, and 36 to 40. Those are the classes. So we have 5 total classes here. 1, 2, 3, 4, 5 classes. And it illustrates exactly what I said, right? 10 represents the number of data values that lie between 16 and 20. So we have 10 people between those individual categories themselves. Okay, that's pretty much what we're going to deal with in this couple sections itself. Okay, now the next couple definitions go along into actually describing the frequency distribution, because essentially our goal is starting with this, can we ask us some questions, and then given the raw data, how do we actually construct this from scratch, right? So we're slowly going to gear towards that kind of concept itself. Okay, but a couple more definitions before we get into more stronger examples. Okay, so next definition is called a lower class limit. Okay, so a lower class limit are the smallest numbers that can belong to the different classes. So for instance, I have a lower class limit of, let's say, 16, right? That's the minimum number of age someone will be between, in the class of 16. So because of that, we also have an upper class limit, and it's just the opposite definition. It is the largest numbers that can belong in the different classes. So for example here, right, 20 is the highest age someone could be within 16 to 20, that class itself. So that represents the lower and upper classes. And the last one is called the class width. So the class width is the difference between two consecutive lower class limits of a frequency distribution. Now, difference. Difference means subtract, right? Subtracting stuff. So we're subtracting two consecutive lower classes. Now here's the thing. What does consecutive mean? So consecutive means right after another. So, right, so for example, 7 and 8 are consecutive numbers because they come right after another in the sequence. Same thing applies here, okay? So here's a little example illustrating our 3 new definitions based off our frequency distribution on top. So we have so all we want to do is list out all the lower class limits. Meaning we do have more than one, right? Because we have 1, 2, 3, 4, 5 classes, which means you should have 5 lower class limits and 5 upper class limits. So the lower class limits are literally these numbers because in each class, these are the smallest age groups you could be to be in each individual class. And therefore, these ones over here will be considered the upper class limits, right? Because of the largest numbers you could be, and still be in that same class itself. Okay, so hopefully lower class limits, upper class limits are pretty straightforward when it comes to it, right? Now the class width is the difference that we're subtracting of two consecutive lower classes. So I mean, all we're doing is looking at these, and we're picking two consecutive, so like 16 and 21, right? These are one after another. So what is 21 minus 6? 5, which means our class split width would be 5. Okay. Now the cool thing about the class width is you actually don't have to do the first two. You can do the second two. So you could do these two. So what's 26 minus 21? Also 5. You could do the other ones. What's 31 minus 26? 5. And the last one's 36 minus 31, also 5, right? Now, obviously, you can't do like 26 minus 16 because that's not consecutive, right? You're skipping one. So that's what makes consecutive one after another. And notice they're all going to be 5. Okay? And notice there's an order, right? 5, 5, 5, 5 going down. So it's not just, it's pretty nicely properly broken down when it comes to, so that number should not change as you see them down here. So that's where you find lower class, upper class, and the last thing is the class width. Okay. All right, so here goes a question for you guys. See when it comes to it. So why don't you guys find the all three things: the lower, upper, and class width for each of these uh, examples here. So you can go ahead and pause the video and then try them, and then we'll do them together. So 3, 2, 1, pause. Okay, so hopefully you guys tried them. So I'll just go list them out. So let's go here. So lower class limits here would be 10, 16, 22, 28, 34. Upper class limits would be 15, 21, 27, 33, 34. I'm sorry, 39. And the class width, so I'll say CW for short, should be 16 minus 10 should be 6, right? And again, you could do any two, you get 6, right? So hopefully you got that one right. Over here, the lower class limit should be 0, 4, 8, 12, and 16. Upper class limits should be 3, 7, 11, 15, and 19, right? And then the class width would be, let's say, 4 minus 0, or 4, right? And there we go. And again, you can do all the ones, right? 16 minus 12 is 4. It's always going to be the same number either way. Okay? And the last example, lower class limits 10, 20, 30, 40, 50. Upper class limits 19, 29, 39, 49, and 59. And then finding class width should be 10, right? 30 minus 20, 10. So hopefully these aren't too bad, right? Those definitions aren't too bad to deal with when it comes to it. Now that we have a little bit of background information, how, what's frequency distribution, we can label some stuff off as well. How do we construct this from scratch, right? So in other words, how can we use the raw data and then actually make this here? So in other words, how do we do this just given raw data, okay? And we're actually using the stuff the equation, the definitions we used so far in a little different way, okay? So now it comes to our next concept. So it's actually the last concept in this section, okay? Is how do we create a frequency distribution from scratch, from the actual raw data itself? It's actually not that bad. It's just basically 3 simple steps, which, believe it or not. The first step is we want to see how many classes there will be. And usually it's 5 to 20 classes. And here's the key thing. This will always be given to you in the question. You will never have to guess on how many classes you want. Okay, so that's the number one thing I always see when it comes to frequency distributions, how to construct them. People add more classes than I want or less classes because they're not sure how many classes, given. This is not a number you choose. It will be asked to give you. So it will give it to you and told to you. So you don't randomly just guess how many you want. So that's a key thing for number one. All right, so number 2, class width. So we defined class width before, right? It's a difference between two consecutive lower classes. But the problem is, well, we don't know what these numbers are going to be, right? We're actually construct this from scratch. So believe it or not, we actually have a new equation, a very special equation for something called class width. So the actual class width equation is the largest value minus the smallest value divided by the number of classes wanted. Okay, so right, subtract, then divide. So, and again, we always round to the next whole number when it comes to class width. Okay, right? So round up or round down, depending on, actually, we'll always round up. How about that? We always round up. How about that? Make it easier. So even if it's a decimal, just round up. Okay. And then lastly is we're going to choose a lower class limit for the first class. And usually the best thing is we're always going to be starting with the smallest value in our data set. That's basically that number here. That's our starting point. So in other words, in this frequency, in this data set, 10 was the smallest number in the data set, 0 and then 10 itself there. Okay, so that's what we mean by step 3. Okay. And then now I give you an example how we're going to do these steps to figure this out. Okay, so given the data set of numbers of times and minutes of movies, create a frequency distribution with 5 classes. Now notice, there's your step 1, 5 classes. So that step 1 is done, identifying how many classes you want. Okay. So now we go on to step 2. So step 2 says we want to find the class width. So we want the largest number and the smallest number. So the largest number in the data set is right here. Smallest number in the data set is actually right next to it. Okay. So we subtract and then divide by how many classes we want of 5. So subtracting divided by 5 gives you exactly 36, which means we do not have to round, right? It's a whole number, so we're good. Okay. So now we're done with step 2. Okay, so that is step 2. Now for step 3, we want to identify our lowest one, right? Our starting point. So step 3 says we want to find the smallest number of the data set. So in our case is 142, and that's going to be our starting point. So in other words, if I do, right, this is my starting point, 142. Now we go back to the second definition of class width. Okay. Well, remember, right, we're doing this from scratch. We're going backwards. So here, we subtracted 16 to 10 to get 6. So how do we get, given our class width of 6 and starting from 10, how do you think we get to 16? We add them, right? 10 plus 6 gives you the 16. So that's exactly what we do here. So to find the other class, the next one, it's like, in other words, going down the column, all we're going to be doing is adding our class width over and over and over again. For example, 36 plus 42 gives you 78, which means that's our next lower class. And then we keep going. 178 plus 36, 214. 178 plus 36, 214. 214 plus 36, 250. And then finally, 250 plus 336, 286. Okay. Now notice we did these first, right? These are the dids first. And now, we always do lower class limits first. Now we're going to do the upper class limits. Now the upper class limits are much easier because all you're going to do is subtract 1. So in other words, what's the next lower one from 178? 177, right? Minus 1. Minus 1, 213. Minus 1, 249. Minus 1, 285. And then from here, notice if you could just add straight down, that gives you plus 36, plus 36. So plus 36 here gives you 321. Now, interesting fun thing. Notice this is not in my data set. This is 235. All right, so 230, 222. It's not in here, right? This only goes up to 321. That's okay. Do not force your data set, your frequency distribution to figure all of it. So if it stops here, do not force it. Stick with that portion, okay? You have no idea how many people actually try to force everything because everything is organized, right? So I should literally subtract any two numbers, consecutive two numbers, and still get your 36. So that doesn't mean just, tweak it to make it that one there. Just assume that's okay. And we'll talk about why that's true in chapter 3, why sometimes your data set doesn't imply everything. Okay, so that's okay. All right, last step is to find these numbers here. So like I said, right, all this saying is going back to the data set. You're going to count how many numbers in my data set are between 142 and 177. So at this one, you're just counting, right? So how many numbers between 142? There's 1. And what's any others? 2. There's only 2. So we have 2. So going back here, how many numbers in your data set are between 178 and 213? So again, count, and you should get 10, and you slowly go down the list.